In this video, I'll explain Newton's law of cooling. The Newton's law of cooling states that the temperature of a body changes at the rate which is proportional to the difference in temperature between that of the surrounding medium and that of the body itself. Suppose you have a cup of hot water here. This is hot water. So you have kept it on table. After some time, the water cools down. Suppose body is at a temperature of theta at time t. Okay, and surrounding temperature is theta naught. Then this theta gradually decreases, and at some point of time that will be equal to theta naught. The temperature, it passes its heat to the surrounding. So mathematically, the Newton's law of cooling is represented as d theta by dt equal to minus k into theta minus theta naught. So the proportionality constant is k. There is a minus sign because the temperature decreases. Initially it was very hot, then it gradually comes down to the temperature theta naught, temperature of the surrounding. So that's why the sign minus. It is a first order first degree differential equation. There are different methods to solve first order first degree differential equation. The variable separable method is used to find the value of theta at any time t. Now the use of Newton's law of cooling means this expression is that suppose you have hot water here and you have placed a thermometer within this. So you have to record the reading after every time, like 10 minutes, after 20 minutes, after 15 minutes, what is the temperature, because it is cooling down. But if you have the expression for theta at any time t, no need to go and check the readings every time. So without being there, if you know the initial conditions like initial temperature and the drop down from the initial temperature by how many minutes, if you know that, then instead of going and checking the reading every time, just with this equation you can predict what is the temperature after given minutes. Now I'll illustrate Newton's law of cooling with an example. So here is the question, first question. If the temperature of the air is 30 degrees Celsius, so this is the surrounding. So theta naught is the temperature of the surrounding, that is given as 30 degrees Celsius. And the substance cools from 100 degrees Celsius to 70 degrees Celsius in 15 minutes. This is the data given. Find when the temperature will be 40 degrees Celsius. That means you have to find the time when the body cools down to the temperature of 40 degrees Celsius. We have to find out T equal to how much. First, let us use the Newton's law of cooling. As per the Newton's law of cooling, the rate of change of the temperature of the object is equal to minus k into theta minus theta naught. So here, let me substitute. This implies d theta by dt equal to minus k into theta minus 30. Now, this is a first order first degree differential equation. This can be solved by the variable separable method. That is d theta, theta terms on one side, theta minus 30, I will bring it to the left hand side, minus k into dt, dt on to the right hand side. Now integrate on both sides. You will get log of theta minus 30, which is equal to minus k into, minus k is a constant, integral of 1 with respect to t is t plus some constant of integration. I will add particularly log c. That is because there is log on the left hand side. That makes the simplification easier. You can add any constants, but I will particularly choose here the log function with a constant c. Totally altogether it is a constant. Now you can simplify this further taking exponential on both sides. Exponential log cancels. Theta minus 30 equal to e to the power minus kt plus log c. Okay, this is theta minus 30 equal to, this can be split as e to the power minus kt into e to the power log c. So e to the power minus kt into e to the power log c, exponential log again cancels, you will get c. So c into e to the power minus kt. This is your equation 1. Now after getting this plays an important role. Now this is the solution of that first degree differential equation that gives you temperature of the body at any time t. Now here initial temperature is 100 degrees Celsius. Initially the body was at temperature 100. So when t equal to 0, initially means t equal to 0, you will get theta is equal to 100. Let me substitute that here. So then 100 minus 30 equal to c into e to the power minus k into t is 0. E to the power 0 is 1, hence c value is equal to 17. So initial condition gives you the value of constant c. Now next you want the value of the constant k. So to get that k, you make use of this condition from 100 degrees Celsius to 70 degrees Celsius after 15 minutes. So when t is equal to 15 minutes, the temperature of the object is 70 degrees Celsius. Therefore, let me substitute that here. 70 minus 30 equal to c is 70. I will substitute e to the power minus k, I don't know, into t value is 15. Let us simplify this. 70 minus 30 is a 40. So you will get here 40 by 70. Bring this 70 to the left hand side. E to the power minus 15 into k. You can simplify this further as e to the power 15k is equal to, I will write this as 1 by e to the power 15k. So e to the power 15k equal to 0 cancels. You will get 4 by 7 here. So 1 by e to the power 15k equal to 4 by 7. So cross multiply now. So e to the power 15k is equal to 7 by 4. Now you want the value of k, take log on both sides, then you will get 15k is equal to log of 7 by 4. This is log to the base e, okay, because the e has to be cancelled. So you can either write ln just to make sure that it is natural logarithm, or else you can write log, but to the base it is e. Now k equal to 1 by 15 into log of 7 by 4. This is the value of k. So we got the value of constants c as well as k. You can substitute back into the first equation. So what it becomes is theta minus 30, which is equal to 70 into e to the power minus 1 by 15 into log of 7 by 4 into t. This is to the power, it is in the power, e to the power. Now they have asked to find when the temperature will be 40 degrees Celsius. 40 degrees Celsius, the object will reduce its temperature to 40 degrees Celsius. When that will happen? So theta equal to 40. At what time this will happen? T equal to how much? So substitute in this. 40 minus 30 equal to 70 into e to the power minus 1 by 15 into log of 7 by 4 into the value of t we have to find out. So keep it as t itself. 40 minus 30 equal to, this gives you 10. So therefore 10 by 70 is 1 by 7. I will write directly e to the power minus 1 by 15 log of 7 by 4 into t. Now you can write it as 1 by this value so that it becomes positive. So therefore you will get 1, this is equal to 1 by e to the power t by 15 into log of 7 by 4. Hence cross multiply e to the power, this is equal to 7. I will write here, that is e to the power t by 15 into log of 7 by 4, which is equal to this 7. Value is equal to 7. Now you can remove this exponential function by taking log on both sides, natural logarithm. That gives you t by 15 into log of 7 by 4, which is equal to log of 7 to the base e. Therefore now I want the value of t. So t equal to, take this to the side, 15 into log 7 divided by It is log of 7 by, so which can be written as log of 7 minus log of 4. Okay, because a log of m by n is log of m minus log of n. So simplify all these values, get the final answer. So the final answer will be 52.5 minutes. Okay. Therefore, the body will come down to the temperature theta equal to 40 degrees Celsius when time t is equal to 52.5 minutes. Now the second problem is a body originally at 80 degrees Celsius cools down to 60 degrees Celsius in 20 minutes. The temperature of the air being 40 degrees Celsius, what will be the temperature of the body after 40 minutes from the original? So let us write the given data first. A body originally at 80 degrees Celsius and surrounding medium is air which is at 40 degree Celsius. Therefore, theta naught is equal to 40 degree Celsius. So, theta naught equal to 40 degree. Now, by Newton's law of cooling, we have d theta by dt. The temperature of the body is directly proportional to the difference between the temperature of the body and its surroundings. So, which is minus k into theta minus theta naught, where theta is the temperature of the body. So let us substitute theta naught equal to 40 here. So we get d theta by dt is equal to minus k into theta minus 40. So separate the variables, variable separable method, d theta by theta minus 40, theta terms on one side minus k into dt. So then integrate on both sides, we will get log of theta minus 40 which is equal to minus kt plus log c. I will take the constant of integration as log c because there is log on the left hand side. Now taking exponential on both sides, we will get exponential log cancels theta minus 40 which is equal to e to the power minus kt plus log of c. You can split this as a power m plus n as a power m into a power n. So this gives you e power minus kt into e power log c which is just c. So c into e power minus kt which is theta minus 40 on the left hand side. Name this as equation 1. Now after getting this, go to this. A body originally at 80 degree Celsius. So originally means when time t equal to 0, the temperature of the object is 80 degree Celsius. Let us substitute that here in the first equation to get the value of constant c. So what we get is 80 minus 40 is equal to c into e power minus k into t is 0 because initial value it is. So e to the power 0 is 1, c equal to 20. The value of c is equal to this 40. So value of constant c is 40. After getting c, go to the next condition given here. It cools down to 60 degrees Celsius in 20 minutes. So when t equal to after 20 minutes, the value of theta is equal to 60 degree Celsius. So substitute that here. Now theta is 60 minus 40 which is equal to c is 40 into e to the power minus k into t is 20. This is in equation 1. So this gives you 60 minus 40 is 20 is equal to 40 into e power minus 20k. So that gives you e power minus 20k is equal to 1 by 2. So it is e power minus 20k is equal to 20 by 40 is nothing, 0 cancels. So 2 by 4 is 1 by 2. So I want to take the reciprocal because then it becomes a positive. So 1 by e to the power 20k is equal to 2. Okay, that is by taking the reciprocal here. So you will get now e to the power 20k is equal to e to the power 20k is equal to 2. That is because 1 by e to the power 20k, then cross multiply, e to the power 20k is equal to 2. So now I want the value of k, so take log on both sides. 20k is equal to log of 2, log to the base e, natural logarithm it is. Therefore, which implies k equal to 1 by 20 into log 2. This is the value of k. We got the value of c and we got the value of k. C is 40 and k is 1 by 20 into log 2. Now using these two, the equation becomes, this first equation becomes 1 implies theta minus 40 is equal to c is 40 into e to the power minus 1 by 20 log 2 into t. Okay, the equation 1 changes like. Now you have to find out what will be the temperature of the body after 40 minutes. So when T is equal to 40 minutes, theta is equal to how much? That we have to calculate. So theta we don't know, keep as it is equal to 40 into e to the power minus log 2 divided by 20 into time is 40 minutes. Now we have to simplify this. So this is equal to, I will simplify this here. I will bring this, I will write it as theta is equal to 40 plus 40 into e to the power. Now this is 2 ones, 20 ones are 22s. So 2 into log of a to the power m is m into log a. So this value whatever here with the coefficient, as the coefficient, that goes to the power of 2. So 21s are 22s it is. So minus 2 log 2 changes to log 2 square, which is log of 4 with a minus sign, minus log of 4. Now this minus also can be taken to the power of the value. So theta equal to 40 plus 40 into e to the power log of 4 to the power minus 1, which is nothing but 1 by 4. Now exponential log cancels, then 40 into 1 by 4 you will get 4 ones are 4 tens. So theta is equal to 50. Therefore, we will get the temperature after 40 minutes is equal to, temperature is equal to 50 degree Celsius.